The Real World Design Challenge is a public-private partnership dedicated to sustainably increasing the STEM workforce. And that's really our goal. We all know why that's important, so I won't go into the reason why the workforce is important. I think everybody knows. The challenge itself is real world in 4 ways. First, the problem is defined by industry and federal agencies, or particularly practitioners who are professionals in the field of aeronautics. They define the problem. Second, we have the students use professional quality tools, real software tools, the same ones that the professionals used in industry and government. Third, the students have a chance to engage in taking on real roles such as project manager, project scientist, project engineer, project mathematician, marketing communications specialist, etc. And lastly, the students have a chance to make a real contribution. And I'll let them tell you a little bit about the contribution when they get a chance to speak, so I won't get into it now. Our partners at the state level are governors. We found that the chief executive in each state, the head of who leads the state, also manages the education programs in the state along with the governor, lieutenant governor, commissioner, superintendent of education. And so our partnership is with the governor in each state. Thus far, we have 30 governors in support of the Real World Design Challenge, and we appreciate that. Our goal is to have all 50 governors on board as we progress through the years of the challenge. So this is our 3rd year, and I think we're doing quite well in that regard. The challenge has 2 parts. There's a state challenge, which we call the Governor's Challenge, and then there's a national challenge. For those who win at the state level, they're invited to go on to the national challenge. The challenge we're announcing today is the state level challenge, or the Governor's Challenge, and the national challenge builds on that, but is a little more complicated. The Real World Design Challenge is supported by a whole variety of partners. As you can see, there's a snapshot of the partner logos on the screen. I'm not going to go through all of them, but I'm going to simply say that each of these partners represent government, industry, and education, the 3 sectors of society that have the expertise to come together and really address this workforce problem, the STEM workforce problem that we're all concerned about. That expertise is particularly important and valuable. No single sector of society has all the expertise that we need to address this problem. So having all of these partners in place is particularly important. Each of these organizations has contributed something to make the challenge free for the teachers and the students. So the kinds of contributions that the partners have made are personnel to help design the challenge, mentors, judges to help evaluate their work, and also some of the partners have contributed cash to help make the challenge free for the teachers and students. I want to give you a snapshot of some of the impact that we've seen over this past year. We found that for 72% of the students, the Real World Design Challenge excited them about STEM fields, gave them new STEM skills, experience, and knowledge, and made them want to pursue fields, careers like engineering, which is what we're hoping that all of them will do, especially the best and the brightest. The students came from a diverse range of social settings, from urban areas, suburban areas, and rural areas. About 42% were minorities, and we're happy about that. We need to get those students who are underrepresented in STEM, particularly minorities and women, engaged. So, because the white male population alone is not sufficient to address the workforce needs that we have. We also found that the students that were engaged in the Real World Design Challenge had positive views of STEM careers as a result of their experience. They found that, that this kind of activity was fascinating, appealing, exciting. It means a lot, and it's interesting. And most of the percentages were about 80% across the board, which is really great. And the kids engaged in a diversity of roles like project manager, scientist, mathematician, engineer, marketing, and some other things. The challenge itself was designed by this year was designed by a team of people. They're listed here. We have people on the team from Cessna, from the FAA, from Mentor Graphics, from NASA Langley, NEI Software, PTC, Rockwell Collins, University of Victoria, and Zona Technologies. I know we have at least two, maybe more people who are on the design team this year in the audience today. Could you please raise your hand and identify yourselves? Let's give them a round of applause. Without their expertise, hard work, and volunteering, the challenge this year would not have been possible. So thank you to all of you and to those who were not here. This is the challenge this year. The challenge is to design the exterior geometry and internal structure of an airliner wing using aeroelastic tailoring methods to minimize the objective function by varying specific design variables without violating the constraints. The variables are up there. I wasn't able to fit the constraints on the screen, so you don't have them, but they're on the website if you're really interested in those. The objective function is there. You can see that that's the formula they're going to be using to work on this problem. They'll get the professional tools they'll be using this year. The tools from PTC include Pro Engineer for computer-aided design, Mechanica for static structural analysis, MathCAD for mathematical work and connection and visualization, and Windchill for collaboration and data management. That's from PTC. NEI Nastran provided NEI software. Z-Aero provided Zona technology. Both of those are used in aeroelastic analysis or flutter analysis for structural analysis in flight. And Flow EFD Pro is used for fluid dynamics testing. So the students make their choice of design not based on a pretty picture or caprice, but based on data, the same way that a professional engineer would engage in designing a plane. So those data help them make choices about which candidate wing design is the most effective. And based on those analyses, they then work through their designs, go through many iterations, and then come up with the best solution. This past Tuesday, the students who were here had a chance to go to the White House Science Fair, and they had a chance to have President Obama review their work. And as you can see on the screen there, President Obama is squatting down and looking at this very poster that the students had in the White House to help explain the work that they were doing. And they were very pleased to explain their work to the President, and I think he said to you, correct me if I get this wrong, he's looking forward to flying on the plane that they designed someday. And this is another snapshot of the kids at the White House. You can see in the upper left-hand corner, the students are there with one of our speakers, John Hickey from the FAA. And on the far right, they're there with Bill Knapp, the science guy. They know these things better than I do. And they were very excited to have a picture with him. And on the far bottom left, you can see the famous picture of John F. Kennedy in his pensive position. The students don't look pensive in the pose, but they really are very pensive people, too. The person on the far right in the lower right-hand corner is Mr. Chopra, who is the President's technology advisor, chief technologist for the President. And with that, I'd like to stop and ask our next speaker from NASA to come forward. Dr. Shin.